everybody. Hey. So my talk is about taming monolithic application architecture. As Tom's already mentioned. There we go. I'm Andre Dublin, software engineer at Power Inbox. We create targeted advertising in email. So check us out. Some cool stuff going on there. So what we'll be covering today is a review of popular application architecture designs. So service-oriented architecture, or SOA, and microservices, CQRS, which is command query responsibility segregation, and domain-driven design. And then we'll look into how we decompose these architectures into modules, but using the iDesign method. We'll look at some classic mistakes, at least in the extreme sense of a functional approach to designing an architecture, and then we'll look at the correct, what I've found to be the most correct way so far, which is volatility-based decomposition. Some terms that I'll be using interchangeably through this talk, things like services, modules, and components. I'm kind of just blanketing it over, so don't get angry or confused. So starting off with SOA. So some people may frown at me for combining these two together because SOA is kind of different, but I feel like microservices is an evolution of SOA. And so some of the pros we have here, we have clear separation of concerns and responsibilities. That is, each microservice has responsibility for one thing and one thing only. So that gives us the ability to have smart endpoints that it's only working on that piece of business logic that you have to worry about. We also get dumb pipes. That is, in terms of Unix, where we query a microservice for information, we get information back, and then we can forward it on to another part of a microservice, or we can work on information and, again, forward it on again. So just like a Unix pipe. You can cat a file, push it onto more, do some other things to it. Scaling. So microservices make it really easy to scale. So we may have endpoints that are being pinged. We don't have to worry about touching any other parts of our system. We just ramp up the number of instances for that microservice. And next, fast deployments. Another benefit that we get, because we can deploy just those parts of the systems that we need to have updated. Now, some bad parts are you get it's distributed, and in a sense that there are languages out there that can handle distributed services, but you will run into situations where you'll have things, for example, like race conditions. When does an update happen? What if another service requires another service to have some information in a certain state? Then, so implementing the use cases that span multiple services. So again, we need data to be in a certain state in order for it to satisfy a use case that our domain owner or business owner wants to have. And then we have implementing use cases that span multiple teams. So you can have multiple teams, different teams working on separate parts of your microservices, and they have requirements based on another team's information, or information that's coming from their endpoint, and that can cause a little bit of pain sometimes too. And then, of course, there's deployment complexity and dependencies as well. So you may have to have services that require or rely on other services to be either running, stopped within a certain state before you can even push a service up. So CQRS, or command query responsibility segregation. So I believe that this pattern has some similar ideas to iDesign, and we'll get to how that relates to iDesign a little bit later. So what we get here is we get a clear separation of concerns and responsibilities. That is, we have one part of our system that handles commands, which are puts, updates, deletes, and posts. Yeah, puts, updates, same thing. And then we have queries, gets. So yeah, queries, commands, but the problem is that we add significant complexities to very simple systems. We're kind of conflating our system into something bigger than it should be. And the last one to go over, domain-driven design. So The bonuses we get with domain-driven design is that we have systems that are very much in linear with the business model. So your domain owners, your business owners, your stakeholders, they come to you, they say, I want a system that is like X, Y, and Z, and you're like, we can do that using this design pattern and make the thing X, Y, Z. So you get your business owners that are able to understand your system. You're not having parts of code or modules or components abstracted away that when they look at the code, they have no idea what you're writing. And then they freak out and be like, why are you doing that? We also have the ability to isolate domain models within contexts. That is, we can have a reuse of our domain models. So take, for example, like a banking domain. And we have an account model. So I can use this account model for an account holder's context. So I can make deposits, make withdrawals. And then I can take that same model and put it into the banking's perspective, where they can add interest or have debits occur, like fees, or even support banking support context where they have to look up your bank account and get information on it. The bad parts of this is, of course, arriving to a consensus. It's always kind of hard to eventually agree upon the nomenclature that you will use that will drive your models, your classes, and everything. It can be difficult for stakeholders in the development team to come to terms on that when finding common terminology. So, for example, take like healthcare. The domain expert would see, I've got nurses, doctors, nurses' aides, nurse practitioners. I'm not familiar with all of them. I would see them as a user with a role, and that's kind of bad, kind of good, but it defines it, for the developer in a simple way that they understand. Another problem that could be is you're domaining all the things, like you're oversimplifying or over-abstracting the terms or your classes and code and components to satisfy the domain model. So the big question that I hear a lot after people see all these patterns and architecture designs is like, how do I get there? How do I reach, from the starting point now to then and achieve that goal? Or how do I take my system that I have now and modify it to get to that point? And I think the answer to that, what I've found in my experience, is the iDesign method. And the iDesign method, I stand on the shoulders of a really, really big giant. His name is Yuval Lowry. He was the one who created the iDesign method. It was originally intended for WCF, Windows Communication Foundation, any .NET people here, architects to be able to create systems that were able to evolve over time. If you'd like to get more information, there's iDesign.net. Quick show of hands, anybody heard of the iDesign method before? One. Well, yeah, you're on last time. All right, so, okay, good. So yeah, he's really big. He consults a lot of teams and trains on architecture and project design. He has participated in the .NET WCF code reviews and pretty much the final product that we work on. Published in MSDN and lots of other technical magazines. So I bow to him. He's pretty awesome. All right, so how we usually compose our application architecture. As soon as we get our requirements in, we start churning away. We're like, okay, let's start breaking down all the functions that we need in order to make this use case work. So when we get into a functional decomposition where the use cases become a direct translation of our systems and components. The problem with that is that our architecture let me backtrack, that we also get into a flow chart-based decomposition where we want to have, when a user does this, then this happens, and then this happens, and then this happens. And basing that, in those steps of those use cases, we get into a problem where we're either rewriting a lot of code, replicating a lot of code, or copying it in places where it shouldn't be. That gives you an explosion of services, big bloated services, or you're creating delicate relationships. We're also coupling multiple services to our contracts, and we are really conflating the use cases to be kind of like the, how can I put, the number one rule, like this is what they wanted, this is what we're going to do, where it shouldn't just be that. It also, what's interesting, it prevents a single point of entry. Now don't think of it in terms of like a web request. Think of it in terms of being able to have your classes talk to one another. So if you're, putting yourself in the kind of pigeonholing yourself with those functional style, then you're not going to be able to have that component perform any other function. So here's an example of when we start making too many services. So here we have, we want the responsibility of the client to compose all of our services in order to get the output of our result. But what happens is we get a bloated client. Now again, try to eliminate that idea of web and just think of in terms of like services and components. So a component could be a client, could be a module, and then these could be other components and modules, and it's talking to it, trying to get information from it. So our first solution to this small problem is to then chain these requests, or chain the, the call of the services together. But we create a problem here because we are causing a bloating of our A, B, and C modules, whereas when we have a problem in C, then we have to babysit it inside B, and we have a problem in B, we have to babysit inside A. So that gives us a lot more responsibility in A, B, and C to make sure that things go smoothly. So if, for example, C fails, then we have to undo B. B fails, and we have to undo A. Now, probably what you're thinking is, well, I can just do a big try-catch and, Pokemon style catch it all. Maybe, but maybe you need to be a little more granular with the code sometimes. So, functional decomposition. So I'm guilty of this, where I've taken a bunch of use cases and I just started coding right away based on the use cases. Like, I've definitely done it. And the result, of course, was a bloated code base and repetitive code, and it was very hard to maintain. The hard part of breaking away from that style of functional decomposition is not being told that it is the incorrect thing to do, but being shown the correct thing to do. So in this example, we're going to think about building an elementary school functionality. In Yuval's talk, which is this based off of, I think I have a link to the video which you guys can reference later. He goes into the concept of building a house, but I kind of wanted to make it my own so I could really get my head around it. So, in the functional decomposition of a school, we have these functions. We've got eating, we've got teaching, we've got transport, maybe I should transportating, I guess now. Recreation, administration, scheduling, maintenance, cleaning. So let's design a school as we would design software. So how would we go about designing transportation? So we would have to create, so let's think that the school handles the transportation. I know probably they don't do that. They license it out to public bus systems probably, but in this example, so we have to create a parking lot for the buses. We have to purchase the buses. We have to hire drivers. We have to assign drivers to bus routes. We have to pick up kids from stops on the route. We have to drop off kids at school. And then we probably have multiple routes throughout the day. Now, there's a lot of real-world constraints preventing us from getting too crazy with our transportation system because it's the physical world. Whereas in software, we don't have that. We can just, the sky's not even the limit. You can just go to space. Doesn't even matter. So in the real world, we have constraints preventing us from creating a transportation system without considering all these things that we also have to worry about. So refueling, communication between buses and dispatchers, a dispatcher, parking, rerouting buses, paying for fuel costs. So that's all different types of functionality we have to worry about. Now, again, we have that physical constraint. So it's like if we get more buses, well, we've already built a parking lot, but we've got to build a bigger parking lot, so we have to start adding to it. We could have probably planned ahead for that type of change. And now that's important that I bring that up. So planning ahead for change, so keep that in mind. So let's look at something a little bit more realistic in a software system. So we have a stock trading system where our stock stakeholders, business owners, whatever, have a set of requirements. And these requirements are, I need to enable traders to buy and sell stocks. I need to be able to schedule trades, issue reports, processing market data feeds, analyze trades. In this case, our client is a browser. After a trade is sent, a trader report is sent, send an email, and we'll have data stored in a persistent database. So what we're looking at right here is the naive functional decomposition of the system. So based on those use cases we just saw, we were like, okay, great. Let's go ahead and start making all these systems right away. All right? So we've got, all right, we can buy stocks, we can sell stocks, we can trade. We got feed processing for stock information coming in. We've got analyzing for making reports and reporting. We've got our 2 databases down below for persistence. The problem with this system, is that we've created an extreme functional decomposition is what you see here. Most people won't do it this bad, but this is like the worst case we want to see. So what we've essentially done here is we've maximized the coupling, and we'll see how that's going to be happening when we start getting into more of these. The problem with our system is that we wrote it for the use cases, but systems tend to change over time. And what if we wanted to have notifications from buying or selling stocks when a report completes? What if we want to switch to a different type of storage? Or what if we want to have a buy-sell option right now, or buy-sell options? So I don't know if anybody's familiar with like futures or options. It's different from stocks, yeah. What if we want to change the language? So the more requirements change, the more we are afflicted by that change. The more pain we have to go through in order to make those changes, essentially. And all these things that I just mentioned, none of those things that I mentioned were part of the original requirements. Those are things that could have a possibility to happen in the future over the lifetime of the system. That is because that's what requirements do. They change over time. And if requirements would never change, then we'd be all out of the job, right? We want things to be changing. So what is the right thing to do, or at least what I've discovered to be a beneficial tool? And that is decomposed based on volatility. Identify areas of potential change and encapsulate that change, right? So it can be functional, but it doesn't have to be domain functional. So you don't have to be coding for the function of the domain, obviously. But you encapsulate that change in services, and then the behavior between those services becomes your domain, right? So then our idea is very simple. If something is volatile, or if you can determine the volatility of your services, your use cases, then you encapsulate it, and if it were change, you've contained that change, which means you've minimized the impact across your entire system. So This was an example that he brought up. It's called the axes of volatility. So we've got two different types. We have a change that happens at the same customer over time, or at the same time across all of our customers. So let's say we have a customer that wants to change. So now we've identified something that we can encapsulate. So we go ahead and cut that off, and we encapsulate that change from the rest of the system. Now we've got some other customers, a bunch of other customers that want something a different way. Like, all right, we go ahead and cut that piece off, and that's encapsulated. So we protected ourselves from having to suffer the movement of, rewriting a whole lot of code in order to allow that feature to exist. And we keep doing this over and over and over again until we've identified all the areas of volatility. So axes should be independent from each other. They shouldn't start crossing into each other, or you're starting to allow multiple areas of volatility to live in one system, and that's not good. So you want to encapsulate those from each other as well. When you're not, you're doing functional decomposition. So things that tend to change at the same customer over time are hardly ever things that different customers would use differently at that same moment in time. And when it doesn't, it indicates functional decomposition. This is not a hard and fast rule, but it's a very good correlation to go about containing the volatility of your system. So going back to the elementary school example, and then using volatility-based decomposition. So say, for example, the payments of a driver. We would then say, we've got payments for drivers, but in a functional world, it would just be within that component of the transportation component. We would probably want to cut that off and make it a payments component instead by itself. That way, multiple services can start talking to it instead of just living inside the driver and having to copy it over and over and over again. So, how do we get started? Prepare a list of areas of volatility, and we do this before architecture, we do this before decomposition, and this is definitely a part of requirements analysis, gathering and analysis. So this is a way for you as a developer to help yourself understand the system, not only from a functional perspective, but how it's going to change over time, and be able to protect yourself when that does happen. The only point of the requirements analysis is to answer what could change. And the goal to answer the question of what could change is that there could be a list of things that change that is never given to you. Like the business owner is not going to know that because they're going to see a feature that might be on a competitor, and they come to you and be like, oh, hey, I want this now. And it's like, well, how come you didn't say that 3 months ago? So you have to sit there and you have to ask yourself, well, what if this? What if that changes? What if this happens? What if they want to do something different here? So now let's look back at the stock trading system, but as a volatility-based system. So here we have in green our clients. In yellow would be our managers and engines. In gray is our access or data access. In blue is persistent storage. And the purple are utility, fuchsia, however you want to put it. So what we've done here, so you've noticed I've got a little terminology here, workflow, access, storage. Workflow will use are the managers, basically. They compose engines that hold business logic in order to achieve your use case. Whereas the clients are just dumb clients that come in, hey, I want to talk to probably a trade workflow. So trader app A would go to trade workflow, trade access, trade storage, and come back. It's very simplified in that sense. So within your trade workflow, you may have more things like buying stocks, buying options, selling options, but it gives you that 10,000 foot view to really help contain the change in your system. So sometimes a single service can encapsulate multiple areas. So again, the trade workflow, holding all that in there. Some areas may map to operational concepts, that is the use cases. So I need the trader app, I need the trade workflow, I need the workflow access in order to say run a report, and then I'll look at workflow storage and trade storage in order to do that. Or I need to consume feeds from different trade websites and New York Stock Exchange, S&P, pull it down into the trade workflow. That might do it, and maybe not. Use the feed transformation engine, store that into a trade access and store it into trade storage. Some mapping is very straightforward. So a trader just wants to query something, trader app A, trade flow, trade access, trade storage, and back up again. Some is complex, where you have to map to multiple systems in order to achieve a use case. So data storage. Data storage volatility is encapsulated behind data access services. So this is definitely a good one-to-one mapping you're seeing right here. Because data storage is very slow to change. It doesn't change a lot. So as architects, we do this without thinking. That's kind of like a thing that happens right away. I have like a model and that talks to a database, or I have a service and that talks to a database. And the reason I call it storage is because it can be really anything rather than calling it a database. It could be a database, it could be a cache, it could be in memory, it could be key value store, it could be a queue. So, avoiding encapsulation, change to the nature of the business. So, this is very res. This is where, I wish I had this image brought up, but there's an image of a pair of high heel shoes that's got like a swimmer's flipper on it. It's pretty silly, but you've got to understand that you don't want to try to encapsulate everything that the business could do. Like all of a sudden the stock trading app might not become like a cooking recipe site. Like that's probably not going to happen. You don't have to worry about that. Or if it wants to like manage rental properties, that's not going to happen. So don't get too crazy. So the hint is that it's very rare that it would change in the nature of the business. It's a design trap, and basically, if you try to do it, it can be done poorly. That is, don't over-speculate the design of the system. So the typical layers that we saw, we had our client that were green blocks, which was a presentation. It can be a user or another system. It can be a variety of client applications and technologies, and it advocates a single point of entry into the system. Our business were the yellow blocks, where we have managers that encapsulate the sequences in the use cases and workflows. A manager may use 0 or more engines, where engines are shared between managers, but engines are, again, could be your business logic. It's not to say that I have to have engines, like you don't have to have that. Your manager might be able to handle the use case that comes in. Maybe you've got a system where you need to transform data before it comes back out, then that could be an engine capability instead of a manager. That way you can share that among multiple managers. Our resource access, which are the gray blocks, encapsulate resource access. They may call resources stored in other services. They can be shared across engines and managers, and they expose the lowest possible business context around resources. And finally, resources, which are the blue blocks, the physical resources, storage, DB, and memory, queues, such like that. And then our utilities, or the pink blocks, so common infrastructure to all services, things like pub sub, logging. I think that's the best two examples I can think of. Things that are not dependent on a use case, but are probably usually best for the developer to have. So definitely logging is one of those, and then pub sub. That's all I can think of. Yeah. That was a little faster than I thought I would do it, but yeah, thank you. Any questions?
So what is your philosophy, and this is a big topic that Chris and I write a dissertation about, on finding those partitions between microservices? So like from like a practical standpoint, you have, I don't know, e-commerce or whatever you want to pick as a domain, right? Like,
Yeah.
what's your process for determining where that boundary should be?
All right. So let's take, for example, like a use case where a user wants to come to the store and buy an item.
Yeah.
Right? So what are the areas of change that can happen there? Or what are the areas of volatility that might happen there? So search, and then in the future, maybe they want, when they purchase an item, that we say, okay, after they purchase an item, I want them to, tag all their friends on Facebook about it, or something like that. Or that's a little extreme. Well, e-commerce is such a well-defined domain.
Or maybe like you have like a video streaming service, or I know like Netflix has struggled with this. They had some good blog posts about it. So I think they've adopted microservices pretty heavily.
Yeah.
A couple other companies similar.
Right. So let's take the video stream, for example. Do some on-the-fly volatility decomposition. So at first it's like, all right, I'm going to be able to stream the service to multiple people. It's like, okay. Then let's say down the road, Netflix wants to be able to have people stream from their own selves, like, Meerkat or Periscope, for example. How do we, as architects, approach that change or contain it before that happens? Now, it seems kind of a far stretch, but it's possible within the bounds of that business domain. The one rule that I like to follow sometimes is that how fast does the system change over time? That is it going to be changing every 5 years? Then you probably don't have to worry about that type of volatility to contain. You can let that just live out there until it happens.
Are you talking about the volatility of the data, or of
no, not of the data,
of the structure of what the business is doing?
Of what the business is doing? Yeah, yeah. Mm-hmm. So, a bad, what if Netflix is like, all right, well, we're streaming. Okay, here's a good example. So if they're streaming video, what if Netflix wants to start streaming music? All right. So you've got all these video codecs and video streaming services. Well, that's all handling video, but we can probably still use some of those streaming services and break that out and have it handle video and audio, right? So it's already probably been bound to the video streaming domain, right? So we would say then, all right, let me go and encapsulate this and let that sit there. Well, then I'll have any other kind of video logic in its own service or component instead. And the way that would probably decompose down to when you start actually writing the code is, probably be a one-to-one mapping almost. Like I've got microservices that handle and scale streaming, and then I've got microservices that handle and scale transposing video, probably.
Okay.
Mm-hmm.
Thanks.
Yes. Back up. That's what
Are you guys putting stuff into production at Power Inbox?
Yeah, that's a good question. I should have brought it up. So, Power Inbox, when I first started working there, it was the legacy code system that I'm working on. And the problem with it is that the old developer approached the system, the domain, with a pattern. Like he's like, I'm going to take this pattern and I'm going to apply it. And that's just wrong. I feel like that's the incorrect thing to do. When you're building systems and writing code, patterns evolve out of that. You just don't take something and apply it and expect it to work. So what happens is we have a lot of bloat, we have a lot of dead code, we have code that's not being used, and now that we're applying this method, we are starting to rip out a lot of things, increasing performance for one, and simplifying the system overall.
Gotcha.
Yeah, so it makes it easier for new developers to be on board to understand. So when I got there, it was just like seriously looking at Greek. Like I couldn't believe it.
Right.
Yeah.
And what language are you in on a day-to-day basis?
Professional C#, but I code all kinds of fun stuff at home, so yeah.
Cool.
Yeah.
I think I have a couple of questions mixed in here, but so with your managers and kind of the workflow business logic at that point, what if you have a client that's requested a specific workflow, so they go to this manager and then that manager reaches out to whatever service access it needs. What if another client comes in with a slight tweak to that workflow? Do you build a whole new manager to manage that workflow, or do you build that logic into that manager, and how have you dealt with that?
Okay, that's a good question. So what I like to do while I'm composing my services to satisfy use cases is I'll actually draw a line from client to manager to access to tape load and draw it back up. Initially, what that does is makes you aware of like database locks. That's a very old thing. We don't have to really worry about that too much nowadays. But if you're diving back into a service or crossing paths with that line, then you've got a problem because you're having cross communication going back and forth. So if we have that tweak in that sense, then either does that tweak initiate enough volatility in order to encapsulate it, or can we keep it in the system still, right? So I think, does that answer your question?
Yeah, I think so.
Yeah.
So another question, and something I'm thinking about is, so right now, we have a relational database, and so when you break this up, you have your trade stores and your workflow storage. So when you're trying to decompose that, to have that persistence at the service level access, where do you put those, kind of that relational, you bubble that back up to your manager, and if you're trying to work with a legacy system that might have that kind of...
So you're saying like if I need to access two different places?
Right.
Right. So again, you take that line, so we come from Trader app A, we got trade workflow, so let's say we need to log in, right? And then we start working. Or we always need to hit the customer database for some reason just to like get their unique identifier to get their trades. So we would come in, we would go to trade workflow, down to customer access to the customer storage, come back up, down to trade access, down to trade storage, back up to the client.
I got you.
Yeah?
Yeah.
Mm-hmm.
I think that's all I have.
Yeah. Yes.
When you're brainstorming about potential volatility in the future, do you have a process for figuring out what's plausible and what's not, what's too much of a stretch?
Yeah, so that idea of the business domain entirely changing, that's probably like, all right, let's not get too crazy with it. Being able to predict all of it is not possible, but being able to predict some of it and then encapsulating that change will cause less pain in the future. So you'll be prepared for that now when you get to, 4 months down the road, 5 months down the road, something like that. Yeah.
Now, is that something you like consult with yourself? You obviously don't tell the company that you're thinking about them doing this in the future. That's just something you prepare, or?
Oh, okay. So trying to sell it on them?
Yeah. Well, I mean, is
Right.
that something that you keep to yourself in a way to prepare yourself for the future, or
No.
do you recommend it to them? Or?
Yeah. This is definitely like a company thing. You would be like, hey, we've got architecture review. This is what we think would be the better approach. Yeah. So yeah, definitely. I saw another hand. Yes.
My question was similar. So maybe my question changed a little bit now. So the precursor to having this conversation, this architecture conversation within your company, what do you generally ask of the business to kind of feel out what those potential future things could be? Like, because my question was going to be which stakeholders would be in this conversation. Like, if you're having this conversation just within your team, and kind of how do you pull out the need to know information from your client or the business or whoever to kind of predict some of those or kind of give pointers for things that they're considering down the road,
Right.
to know what you need to worry about in the future. Does that make sense?
Yeah, that does. And the problem is that they won't know because they're kind of like, either they're, with blinders on, they're focused on the product then, or if they're savvy enough and you're lucky enough to have somebody who's going to be able to give you those requirements that like, oh yeah, we might do something different. Like, okay, great. Let me go ahead and adjust the architecture to be able to enable us to move on smoothly. Again, you're protecting yourself from that pain of having to rewrite a lot of stuff or at least move things around too much.
And
right?
so who from your team would be in on a discussion like that?
So, since this is all internal for us, we don't deal with third-party people. It's like the chief product officer, senior engineer, and probably our CTO would be involved in this conversation. So another, and something, yeah.
Do you have a recent example from Power Inbox that you were allowed to share where you saw some volatility that you encapsulated?
Yes. So we have a system where we're pulling down advertising information from advertisers that we talk to, and what was happening previously was the system was generalizing the data structures that these advertisers adhere to, which there is somewhat of a standard, but then there isn't. So what we did is, instead of doing that, we allowed them to have their free-form data structures. Got rid of all that kind of generic code that was happening, and in terms of also C# actual generics. And instead of generalizing, a class just to be like, you're going to handle all this, we separated out those classes, and then eventually we can absorb those back into like one type of add data access, because we consume it, save it to a database, and then hold it there. And that's it. A better example would be since refactoring the whole system, though, where we've had to improve performance because using Entity Framework, the previous developer had basically like super long-lived Entity Framework contexts, and that's bad because Entity likes to be quick and done with it. So ripping out parts of the system and circumventing code paths in order to help us do that without trying to guessing what we needed to do first. We sit there and map it out first, like what do we need to do in order to make this work efficiently.
Like,
Yeah.
Evolving from that monolithic system to the microservices system, has that impacted any decisions for your server infrastructure, like something like AWS Lambda or something like that?
Not really. We use Azure, so it's fairly simple because it's a platform as a service, and we really don't have to worry about it too much. I mean, the only challenge that we've come across is just deployments, and that is we have some services that are relying on another service to be awake, so we have to stop that first and then bring up the service and start it again, and that takes time. So it'd be nicer to like just write a batch script or a PowerShell script or something to do that, but that hasn't really affected us too much now.
We were just talking about that at lunch. So.
Okay. Thank you.